All right, and welcome to Thursday. Okay, so today, we're going to continue with writing and graphing inequalities, but today we're going to be using those in real life application problems. So tying them into real world situations. So let's look at our first example. All right, put that in presentation mode. So example number 4, the NASA solar probe can withstand temperatures up to and including 2,600 degrees Fahrenheit. Write and graph an inequality that represents the temperature the probe can withstand. So in order to successfully answer this problem, what I need to do is I need to create an equation, an equality based on the situation. So I got to write an equality, and then I'm going to graph it. Okay, so let's go ahead and begin. All right, so what is this saying? The NASA solar probe can withstand temperatures up to, including 2,600 degrees. So what this, the first part of the problem is saying is that this probe cannot exceed 2,600 degrees. If it's in temperatures above 2,600, it's going to start breaking down. So that's the max. So that's the hottest it can go. All right. So the probe. What's going on here? The probe. I'm going to write this out. The probe cannot. Be in temperatures greater than 2,600 degrees Fahrenheit. Right? That's the max. Right? So I need to write an equality based on the situation. So my quality, I'm going to use T for temperature. So I'm going to go over here, T for temp. All right. So the temperature that the probe can withstand, so T, and then I'm going to compare it. So 2,600 is going to be the max. All right. So T is going to be less than or equal to 2,600 degrees. Right? That is the highest. Anything below 2,600 degrees, including anything 2,600 degrees or below, and that probe is going to be just fine. All right, so we can say this inequality, T is less than 2,600 degrees. Okay, so now I'm going to graph it. All right, I'm going to use what am I doing? I'm going to use black. So I'm going to build a graph. I guess I'm using red. Actually, I don't like that. Let me. So I'm going to build a number line. And your number line may slightly vary. It doesn't matter as long as you have the values included. And I'm going to just start with 2,600. So I got 2,600. I'm going to skip that. That'll be 700, 2,800 on that side. And I'm going to go to the other side. I'm going to skip one. And then we'll say this is 2,000. So that'll be 2,500, 2,400. So I'm going every two. Right? And then if I kept going, that would be 3,000, 3,200. If I kept going this way, it'd be 2,200, 2,100. So I'm going back. All right. So I'm going to go ahead and plot I'm going to go put my circle. And I'm going to go ahead and use a different color at 2,600 degrees. All right. So I'm going to use open for now. So if you remember, open, the value is not included. Hopefully you get what I'm saying. On the edge of my computer. And then close, the number is included. All right, so let me go, since 2,600 degrees is the max, but it can still reach that temperature, I'm going to go ahead and circle my my circle in, because it can be 2,600 degrees. It just can't be higher than that. All right, and since T is less than 2,600 degrees, I'm going to shade in to the left of my circle, because that's anything over here is going to be less than 2,600 degrees. So I'm going to shade all this in. All right, and so my inequality, so T, in order for this probe to work fine, T can be any value that is 2,600 degrees or less. All right, so this is the first part of the question, my inequality, and this is my graph. Okay, and so I'm going to go ahead and erase this. Where's there it goes. All right. All right, and so I'm just going to see it in different words. So words temperature up to and including 2,600 degrees. T represent the temperature the probe can withstand. And so my inequality is 2 is less than or equal to 2,600. And and there's my graph. So they had, so pretty much the same graph that I had, just a little bit neater with the digital copy. Okay. All right, let's go ahead and go to, what I want you guys to do is I want you to go ahead